I'm Matt Christie from TRC. Welcome to our Heat Pump Boss series, Level Up Your Heat Pump Installs. We've got the tools, tips, and how-tos to help make you an expert heat pump installer. Today we're going to focus on load calculation quality control. Let's dive right in. Accurate load calculations and then matching the system to those are the foundation of efficient HVAC system design. But we also know load calcs notoriously fall into the garbage in, garbage out conundrum. It's easy and common to create a manual J result that doesn't actually match the home's load. In this video, we'll cover what not to do when using manual J, some high priority quality control checks you can do on the inputs, and some key things to look for in the outputs that might indicate a mistake. Let's get started. So first off, here's what not to do. First, don't add extra safety factors. Manual J already includes built-in safety margins, typically around 20% oversizing, maybe more, so don't add on top of that. Next, trust the ASHRAE or ACA design temperatures, which recommend the 99th percentile dry bulb temperature for heating and the 1st percentile for cooling. Next, trust what you saw in the house. We see a lot of load calculations where the author pads the R values or U factors of certain ceiling, floor, window, or wall components. Don't. What you see is real. ACA itself espouses aggressively accurate inputs. I love that phrase. Trust what you see. A big one for manual J software novices: don't include walls, ceilings, or floors that separate conditioned spaces. These are called adiabatic surfaces and should not factor into the results. This mistake is common when modeling a multifamily apartment. Like the walls that connect to the hallway or other units don't have any heat loss across them, and so shouldn't be part of your model. Next, when it comes to ducts, don't just assume they're unsealed or uninsulated. If they're fully sealed, give them credit in your calculations. Similarly, give full credit for efforts to produce a tight building envelope. Ideally, your air sealing data entry comes from the results of a blower door test. If you have those results, always use them directly rather than relying on the tight, semi-tight, average, semi-loose, loose pick list options. If you don't have a blower door result, really make the right assessment on infiltration. You can see our video that covers that process and then trust the result. Finally, remember that manual J is designed for residential applications. For commercial or large multifamily, use manual N instead. It's the right tool for the job. Once you've built your model, check over some key inputs that are easy to get wrong. Start by verifying the conditioned square footage. It can help to cross-check this with public records or what's listed in websites like Zillow or Redfin. But note, if the house has had a recent addition, those sources may not be up to date. Next, double check again on those adiabatic surfaces. Don't include them in your model. And then we can do some sanity checks. The total glazing area for most homes is typically 10 to 20% of the conditioned floor area. Homes with over 20% glazing exist, but if you're in one, you'll feel it. You'll see it. It feels like a fishbowl. Windows are a weak point in the thermal envelope, so getting them right really matters. Another easy check: confirm that the total ceiling area and total floor area are almost the same amount. Sometimes ceiling area is a little bit larger due to vaulted ceilings at an angle, but with flat ceilings, the numbers really should be exactly the same. If you're off by a lot, more than 10%, you likely made a mistake somewhere in the inputs. If you're designing a ductless system, make sure that's reflected. And finally, check your design temperatures. ACA or ASHRAE's 99th and 1st percent dry bulb temperatures for outdoors, like we talked about before. And for indoors, use 70 degrees Fahrenheit for heating, 75 degrees for cooling, and do a quick check that use the default for relative humidity, typically around 50%. And once you've done your load calculation, check the results. Percent of total load by component can help you spot major mistakes. The windows and the glass doors, that should be about 15 to 30% of the load. Above grade walls should be between 10 to 30% of the load. Below grade walls, 20 to 40%. Now, this is if you have below grade walls, and this is especially true in cold climates. If they're uninsulated cement or brick, you can get a big loss out of those walls. Ceilings should be 10 to 30%. Infiltration should be 5 to 30%. The doors, typically tiny, at most 5%, more like 1 or 2. The ventilation, 5 to 30%. Next, check the balance between the total heating load and the total cooling load. In New York and cold climates, heating loads are typically 1.5 to 3 times larger than the cooling loads. Now, the further north you are and the worse the envelope quality, the larger the ratio. Now, keep in mind that Smaller or larger values in all of this are possible. It depends on the climate and the construction components in the house. Now, if there is a component that's higher or lower than the range, think about the house. Is there a logical reason this might be so? And if not, check your inputs. All right, thanks for diving in with us on load calculation quality control. Remember, we're here for you at cleanheatconnect.ny.gov with more videos, resources, guides, and best practices. Hope to see you in our other sessions as we complete better installations together, one project at a time.